audible? Hello.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
See, yes. See, last class they will give u is equal to f of x by some condition u there where f of x y is equal to 0. Then if they ask what you will do, dou u by dou x is equal to du by dou x, dou u by dou x in plus dou u by dou y into dy by dx. That dy by dx you can find out from the condition. Correct?
Yes, sir.
Now we can see. Find du by dx. Du by dx if u is equal to tan inverse x by y, where x square plus y square is equal to a square. You know condition is one condition given, so du by dx formula is what? Dou u by dou x plus dou u by dou y into dy by dx. This dy by dx from this condition we get f of x f by x by. Now find out. Come on, do. Now complete that. What is dou u by dou x? Tell me. Tan inverse x by y. What is dou u by dou x? Are you there?
Yes, sir.
What is dou u by dou x? 1 by 1 plus x by y whole square into what you will get?
1 by y, sir.
Y. 1 by y you will get, not 1 by y square. Similarly, dou u by dou y what you will get? 1 by 1 plus x by y whole square into what you will get?
minus 1 by y square.
Minus x by y square will get x also there. Right? Dou u by dou x is equal to 1 by 1 plus x by y whole square into 1 by y. If you simplify, what you get actually? Y square by x square plus y square into 1 by y. So that is equal to y by x square plus y square. Dou u by dou by what you will get? 1 by 1 plus x by y whole square, then minus x by y square. If you simplify, what you will get? Y square by y square plus x square into minus x by y square. Y square cancel. This is what? Minus x by. Correct? Check. Don't copy down blindly. Try to understand and do. Now, dy by dx, what you will get? From this you can do. Dy by dx is what? Minus fx by fy. That is equal to what? Minus 2x by 2y. That is minus x by y. Sir, are you ready? Any problem? Are you there or not? Nobody talking today. What happened?
No, sir, no problem.
Yes, sir.
Okay, good. Very happy. Please respond. Now substitute in formula in this. Everything available. Dou u by dou x available. Dou u by dou y available. Dy by dx minus x by y. Substitute there. What will you get? Dou u by dou x. What is dou u by dou x? Y by x square plus y square minus dou u by dou y is what? Minus x by x square plus y square. Then dy by dx is what? Minus x by y.
Yes, sir. 1 by y.
Yes, sir.
Correct? Huh?
Yes, sir. 1
Yes,
by
sir.
y.
Operator is right or wrong?
Right, sir.
Cancel or not easy? Yes. Nice. Then answer is what? Next. See, Taylor's expansion Suresh are completed. Okay, clear all of you that.
Excuse me, sir. Sir,
Yes.
the board is a bit unclear, sir. It's a bit blurry.
What?
The video is a bit blurry,
Uh,
sir.
Sir, we can't see your writing clearly.
My laptop clearly and not clearly now.
It's fluctuating, sir.
Ah, maybe it's focusing. I think so. Maybe net internet because this I am using my internet only. I am not using university also. That is not very weak in morning or evening.
Oh, it's trying to focus on you every time you move. That's
Yes,
why
yes,
it gets
yes.
blurry and clearer.
That time I want to off actually. I don't know how to do it. In any settings is there. iPhone how to do that. Any one of you tell after finding. Because focus, when I am here, board is clear. I think so. Focusing my face. I
So
want
it
to tell
focuses
Sarah.
on the moving object. Like when you move around, then it focuses on you.
I want to stop the focus. I want to check actually settings. Okay, next time we'll see. Otherwise, I want to tell to Sarah, don't focus on this. Okay, clear? Now come on. Taylor's expansion, you are clear. No doubt.
Yes, sir.
F of xy, how can you expand? Tell me. At a comma b means what? F of ab, 1 by factorial, then x minus a into fx at ab plus y. Then second degree term, what how you will get a plus b whole square. A square plus b square plus 2ab. A square means what? X minus a whole square fxx plus 2 into x minus a y minus b into dou square of dou x dou y plus y minus b is 1 by 2 factorial. Similarly, 1 by 3 factorial means what? A plus b whole cube formula can do. You are clear in that, correct?
Yes, sir.
Okay. If I have time again, I will come back last actually. Time we will keep that again. I will teach. Don't worry. Now, maxima minima of two variables. Already one variable maxima minima you studied in your +2 level. What is that? Tell me. How to find maximum minimum is already are done for single variable. Y is equal to f of x means how you will do? Tell me.
Differentiation, sir, I guess.
Differentiation. First derivative, second derivative check, and then we can find out.
Not hearing, not able to hearing.
Sir, first we can find first derivative, and answer we will going to put in second derivative test. Then we can find out maxima minima.
They will give y is equal to f of x means what you will do? Dy by dx equal to 0. You will get extreme points. Then second derivative you can find d square y by dx square. D square y by dx square at this point greater than 0 means what? Great means what? Function attains minimum. Less means what? Function attains maximum at this point. Remember or not?
Yes, sir.
So
Yes, sir. Yes, sir.
Point of inflection you can develop dou cube by dou cube not equal to 0. A lot of things are there done. Concave upward, concave downward. Studied or not?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now you can find out using two variables. How you will do? Now only y is equal to f of x, one variable means you are doing. Now x and y, suppose u is equal to f of x y. How you will do? Z is equal to f of x y. How you will do? Now with two variable, how to attack?
partial differential.
Okay, listen. Maximum minima for two variables. So they will do f of xy. One function they will do. Find the maximum minimum at what points. Then what is the maximum, what is the minimum? Where its maximum is different, what is the maximum different? You can find out at this point my function attains maximum. At this point my function attains minimum. Maybe you will get to different points, you will get attains maximum minimum. But value of maximum minimum is unique. Reaching or not? Suppose one curve traveling like this. Suppose this is maximum means what? Wherever you can go, maximum value is same, but points are different. Here also maximum, here also maximum. So I may get bunch of points. At these places I will attain maximum. If I say maximum value this much means what? That is unique value. Reaching or not? Any confusion?
No, sir.
No, sir.
So I may attain in so many places maximum, but the value of maximum is unique. Only one fellow maximum, only one minimum.
Yes.
I may attain in different places. Correct?
Got it, sir.
Yes, sir.
Oh, right. Now come on. Now, to find maximum minimum, first what you will do? Fx you can find equal to 0. Fy you can equal to 0. Procedure. First what you will get? Fx equal to Fx you can find out equal to 0. Fy equal to 0. You will get bunch of points. Extreme points. x1, y1, x2, y2, x3, y3, so on. Clear? They will do one function. First you can do fx equal to 0, fy equal to 0. Using equating these two, such a way you can solve these two equations. Somewhat you can do, you will get bunch of points x1, y1, x2, y2, x3, y3. How many points are available? That points you will get. Any problem up to here?
No, sir.
Now,
No, sir. No, sir.
actually, see, in partial differentiation, one notation is there. F of x by e is what? Z is equal to f of x by e is what? Okay. This note down. Dou z by dou x they will call P. Dou z by dou y they will call Q. Dou square z by dou x square they will call R. Dou square z by dou x dou y they will call S. Names actually, notations. In third semester it will be useful for you, they will teach the teacher actually. P. Dou z by dou x is equal to P, dou z by dou y is equal to Q, z is equal to f of x y. Dou square z by dou x square is equal to R, dou square z by dou x dou y is equal to S, second derivative. Dou square z dou y square is equal to T. PQRST. First derivative is what? Dou z by dou x equal to P. That is what this is PQ. Fx is P, Fy is Q.
Sir, S is dou x dou y, no, sir?
Dou square z dou x dou y. Second order.
Okay, sir.
That is uxy like this. Any problem? Now, first step is what? Find fx, fy equal to 0, you will get bunch of points. Then you can find fxx, fyy minus fxy whole square. This I can call rt minus s square. Are you agree? Prepare. RT minus S square at these all points. At one by one, all points you can substitute it. Clear? RT minus S square you can prepare. R is what? Fxx. T is what? Fyy. S is what? Fxy. Clear, sir? Hello?
Yes, sir.
Yes, sir.
This is only procedure. You don't worry. While doing the problem, I'll tell you this procedure to understand. Now, RT minus S square you can prepare. All points you can substitute it. Now, if RT minus S square is greater than 0 at x1, y1. If RT minus S square greater than 0 at x1, y1, my function attains either maxima or minima. First door will open. First best condition, if you want to go inside this first qualification is what? RT minus S square greater than 0 at that point is what? At that point, my function attains either maxima or minima. Correct? Reaching?
Yes, sir.
Clear?
Yes,
Yes,
sir.
sir.
So,
Yes, sir.
which points are RT minus S square greater than 0? All points you can take and keep in your hand. So, at that point, my function attains either maxima or minimum. Any doubt?
No, sir.
So, first condition is what? RT minus S square greater than 0 means what? My door will be open. I can go inside. Then further I can play. If it is RT minus less than 0 or is equal to 0, I can't. Procedure is what? Always RT minus S square is greater than 0 means what? At what point this function is greater than 0, I can say these functions, these points are attains maxima or minimum. Correct? Purpose. Next. RT minus X square is 0, then if this is true, my door opened, then R is greater than 0 and T also greater than 0. RT minus S square guarantee 0 at x1 by 1. While testing only you will get, suppose R also greater than 0, R greater than 0 is what, T also greater than 0, no doubt. R is greater than 0, T less than 0 cannot get it, don't worry. So RT minus S square greater than 0 means what? This fellow greater than 0 means this fellow also 0. Then you can say, great means what I said, function attains minimum. Minimum at where? Minimum at x1, y1. What is my minimum? So first what you will do? Fx, Fy equal to 0, you will get a bunch of the points, take all points, then RT minus S square you can find Fxx and Fyy minus Fxy whole square. Each point you can substitute it. Which point is greater than 0? That points may be attains. At that points my function attains either maxima or minima. After that checking is what? Greater than 0 means happy. Again taking that points, if I check R and T are greater than 0 means 1 is enough. R is greater than 0 means obviously T also greater than 0. So great means what? Function attains minimum. What is the minimum? F of x1, y1 is minimum. My function at x1, y1 is minimum, but what is the minimum is what? F of x1, y1 is minimum. Clear? Any doubt?
Yes, sir.
Next, for maximum, what you will say? If RT minus S square greater than 0 and R is less than 0 and T also less than 0. Second derivative. Fxx is less than 0, Fyy is less than 0. Now what you will say? Function attains, less means what? Reverse thinking. Function attains what?
Maximum, sir.
Maximum.
Maximum where?
At x1, y1.
Y1.
X1.
What is the maximum? What is the maximum?
X1,
X1,
Y1.
Y1, I am the maximum. But what is maximum value? F of X1, Y1. In function, you can substitute it. Clear?
Okay, sir.
Okay, sir.
Yes, sir.
Point is different. Maximum value is different. That's what I am stressing. If I go 15th floor means what in my UB university building in Tekpa, actually in SRM, I am the highest place. Where I am highest place means what? 15th floor. What is the height means what? You should measure actually from down actually. 15th floor means what? Maybe 300 feet, 400 feet like this. Clear or not?
Yes, sir.
Yes, sir.
So, now what you will get? RT minus S square gravity greater than 0. Then only door open. Then if R also less than 0, T also less than 0, except X1, Y1. Some points you will get less than 0, some points greater than 0. But 1 is greater than 0 means what? T also greater than 0. 1 is less than 0 means what? T also less than 0 at that point. Now function attains what? Come on. Function attains what?
Maximum.
Maximum. Get what? Maximum at X1, Y1. Now, who is the maximum?
Fx1, y1.
X1, Y1.
F of
F
X1,
of
Y1.
X1, Y1 is maximum. Clear?
Yes, sir.
Yes, sir.
So, at this point, I am reaching the maximum. What is my maximum is what? F of X1, Y1. Clear?
Yes, sir.
So, what is the procedure? Fx equal to 0, Fy equal to 0, then Fxx minus Fxx into Fyy minus F of xy whole square. At these all points you can check if it is greater than 0. So, function attains maxima minima at that point. After that is what? If it is Fxx greater than 0, Fyy greater than 0 means what? Great means what? Function attains maxima at this. Great means minimum. So, F of x1, y1. R is less than 0, T is less than 0 means what? Function attain maximum. So, function F of x1, y1 is maximum. Clear? But RT minus S square guarantee greater than 0. Clear?
Yes, sir.
Yes, sir.
Any doubt?
No, sir.
Shall I above? Noted down?
Yes, sir.
Just close your eyes and recall fx is equal to 0, fy is equal to 0. I will get the bunch of points. Then I want to find fxx, fyy minus f of xy whole square, all these points. Suppose f of RT minus S square greater than 0 means what? My function attains either maxima or minima. After that, I want to check fxx, fyy at that point. While doing RT minus S square only, you will know greater than 0, less than 0. Don't worry. So, R is greater than 0, T also greater than 0 means my function attains minimum at x1, y1. F of x1, y1 is minimum. Then RT minus S square is greater than 0, R is less than 0, T is less than 0. My function attains maximum at x1, y1. F of x1, y1 is maximum. Like sing a song like this has to come to flow. Close your eyes and just stick and recall. Clear?
Yes, sir.
Any doubt?
Yes, sir. No,
Shall I
sir.
No,
stop
sir.
now? Copy?
Yes, sir.
Yes, sir.
Now, next case. If RT minus greater than 0 only, you can test R is greater than 0, T is greater than 0, or R is less than 0, T is less than 0. Second case. If RT minus S square is less than 0 at x1, y1, at x1, y1, then function attains neither maxima nor minima. These points are called saddle points. RT
Sir,
minus
repeat,
S
please.
square. What?
Repeat, please. On the points.
Saddle points. RT minus S square less than 0 at x1, y1 means what? Function attains neither maxima nor minima, and x1, y1 called saddle. RT minus S square less than 0 means what? Function attains neither maximum nor minima. That points are called saddle points. So at saddle point, function never attains neither maxima nor minima. That is neither maxima nor minimum. Okay, clear?
Yes, sir.
Next, case 3. If RT minus S square is equal to 0, we go for further investigation. That's enough. No need to go very deeply. RT minus S square is equal to 0 means what? We go for the further investigation. Any
The
problem?
video is gone.
On coming, I think so. Clear, sir?
Yes, sir.
Now tell
Yes, sir.
how your procedure is what? F of xy in your hand means what you will do? Tell me. What you will do first?
So can you
Find
repeat the
fx
question, sir?
and y equal to 0, you will get bunch of points x1, y1, x2, y2, x3, y3 is called extreme points. Then what you will do? RT minus S square prepare at these points. If RT minus S square is greater than 0 at these points, my function attains either maxima or minima. Then next, if RT minus S square is greater than 0 means what? R is greater than 0, T is greater than 0 means what? Function attains minimum at these points. What is the minimum means what? F of that point is minimum. Next case, RT minus S square is greater than 0, R is less than 0, T is less than 0 means what? My function attains maximum at x1, y1, f of x1, y1 is minimum. Next case is what? RT minus S square is less than 0, function attains neither maxima nor minima. These points are called saddle points.
Saddle points.
RT minus S square is equal to 0, we go for further investigation. And what is there? Any problem?
No, sir.
Let's read again once again. Then give that means 217. 17 first name, right?
Yes, sir. Present. 217 present.
18. 19. 217 present 18. 19.
Present, sir.
20.
Present, sir.
21.
Present, sir.
22.
Present, sir.
23.
Present, sir.
24.
Present, sir.
25. 25. 26. Absent. 27.
Present, sir.
28. Absent. 29.
Present, sir.
Absent.
29
30.
present. Present, sir. 29.
Present.
Sir,
30.
26 is present.
Huh?
26.
Sir, 18 present.
Huh?
18 present, sir.
What are you doing in college? Okay. 29 present. 30.
30 present, sir.
Present. 31.
Present, sir.
32.
Present, sir.
33. Absent. 33. 34.
Present, sir.
35.
Present, sir.
36.
Present, sir.
37.
Present, sir.
38.
Present, sir.
39.
Present, sir.
40.
Present, sir.
41.
Present, sir.
42.
Present, sir.
43.
Present, sir.
44.
Present, sir.
45.
Present, sir.
46.
Absent, sir.
Absent, sir.
47.
Present, sir.
48.
Present, sir.
49.
Present, sir.
50.
Present, sir.
51. 51 is there, huh? 51 absent. 52.
Present, I think. Sir, present, sir.
51 present, okay. 52
Present, sir.
present.
Present.
53,
Present, sir.
54,
Present, sir.
55.
Present,
Okay,
sir.
55. 55 present. 56,
Present, sir.
57,
Present, sir.
58,
Present, sir.
59,
Present, sir.
60,
Present, sir.
61, 61 absent. 62,
Present, sir.
63,
Present, sir.
64,
Present, sir.
65,
Present, sir.
66,
Sir.
66 present. 67,
Absent, sir.
67, 68,
Present, sir.
69,
Present, sir.
70,
Present, sir.
71,
Present, sir.
72,
Present, sir.
Present, sir.
okay, 2 people killing. 73,
Present, sir.
74,
Present, sir.
75,
Present, sir.
76,
Present, sir.
77,
Sir.
78,
Present, sir.
79,
Present, sir.
80,
Present, sir.
81,
Present, sir.
82,
Present, sir.
83,
Present, sir.
84,
Present, sir.
85,
Present, sir.
86,
Present, sir.
87,
Present, sir.
88, 89.
Absent, sir.
Sir, 72 put in chart box. I told you don't put in chart box. This time I will next time over you. 72%. What are the options? Wait. 25, 28, 28 present.
18 present, sir.
261, sir.
Sir, 261 be present.
Sir, 218 present, sir.
2 and 8 I am not given option. 25, 33, 46, 67, 89. Correct?
Already.
Yes.
What? Anyone is
Yes.
there? Yes, tell me. 25, 33, 46, 67, 89. Okay, yeah. Right, sir. Last, you can start and post.